Okay, so for this video, we're going to talk about writing a complete equation. Okay, so you'll often see this instruction, find a complete equation. I'm going to show you two examples today. So a scientist is studying the spread of a new virus among a population of cells. The number of infected cells, M, is modelled by this equation. So we should look at this and try and understand which letters are sort of constants, that is, numbers that we don't know, and which one here is sort of the independent variable, the input, because this is sort of like the output. Okay, T, I strongly suspect it's going to be T, but let's have a look. Where C and P are positive constants and T is the time in hours from the start. Always keep an eye as well on units of time. So this is sort of the input. So the idea here is this is meant to be an equation where you can put a number in, get a number out, or talk about the output, find the input. So it's up to us to find out what C is and what P is. E is, E is Euler's number. So at the start of the study, T equals 0, there were 1,500 cells. Something else I'm going to do is I'm just going to scan the question to check. It does just say the number of infected cells. This will often be the number in thousands or 100,000, so you've got to watch out for that. So I think we can sub in and we can say 1,500 equals C, E, P, and then that's times 0. Okay, so so that's going to mean that this whole part here, where it doesn't become a 0, it will be e to the power of 0, so 1,500 will actually be the C value. Okay. Next, we normally have another piece of information. So exactly 4 hours, the number of infected cells had tripled. So tripled means 4,500 equals. Now C, because we already know what the C value is, we can just use that. So 1,500, E, P is a number that I don't know, but T is 4, so it's 4P. So that's what I need to do. Now, if we're going to solve and try and find this, we need to get E on its own first. So I'm going to get rid of the 1,500 by dividing. So 4,500 divided by 1,500 equals E to the 4P, which means 3 is equal to 4. Sorry, 3 is equal to E to the 4P. How do we undo E? We're going to use the natural log. So the natural log of 3 equals 4P. Okay, and finally, P equals, there's quite a few ways of writing this, but I'm going to write it as a quarter natural log 3. So we're done, right? Well, no, we haven't actually written the complete equation anywhere. So for the complete equation, what we need to do, the actual final answer to A would be to write it. So M is there, but C and P, because those are the constants, when it says complete equation, any constants that can be found need to be written in. So we're going to write this as 1,500 E, and I'm going to write it as, again, a quarter natural log of 3, and just to make it nice and obvious, we'll just write it like that. Okay, so this is when the mark would be scored, and I do actually need the left-hand side and the right-hand side and so on. That's how you score a mark for a complete equation. Next, there is a question. So I've made this as a shadow question from an Edexcel one, and this is the same sort of skill. So hence, find the rate of increase in the number of infected cells, 7 hours. Okay, so rate of increase, you need to really watch out for the word rate. Now, rate of increase is going to suggest that what we actually need to do here is we need to differentiate. Okay, so for B, I would need to find dm dt. And what would that be equal to? Well, that's going to be sort of multiplying the power down to the front and writing the same power again. So not the nicest question in the world, but something along the lines of 1,500 times a quarter natural log of 3. that would be the new number at the front, okay? And then for the E part, so for the E part, I'll just show you the neat answer in a minute. For the E part, it just copies the same as before, all right? So you have E quarter natural log 3t. And then what you would do is you would sub in 7 hours to that one there. So let me show you the neat version of that. Okay, so that's our first one here. Okay, and apparently if we sort of neaten everything up, we get this answer here. So we differentiate it and substitute 7 in, so we get 2,800. Okay, let's do one more example. So again, the main skill we're going to look at here is the idea of finding a complete equation. So a meteorologist is tracking the radius of a circular storm system R T hours afterwards. Okay, so it sounds sort of like this is the sort of the output, if you like. T is the input. And P and Q, A and B, there are certain letters that are candidates to be unknowns. There we go. So we're going to try and find these out. So what are we going to do? Well, we're just going to sub in these values and see what happens. So T hours, yes. The radius, kilometers, yeah. Just checking if I need to change anything. So we're going to do 3.5 squared equals, this was 4, so 4t plus q. And then over here we're going to do, what's that, 7.8 squared equals 12t plus q. Now, these equations are not the hardest to solve simultaneously, but it is just worth saying that generally with Edexcel you don't get credit for this, okay? You know, as long as you're careful, you could write these ones out, you could solve these simultaneously, and you'll get your values for this one, okay? So it will give you your Q value. Hang on a minute, something doesn't look right there. Yes, sorry, these should be P, shouldn't they? Yeah, I'm just checking my work. So, and it should give us a P value as well. Okay, so please don't fixate too much on the method. Of course, if you wanted to show that nice and easily, you could just do 7.8 squared equals 12p plus q. 3.5 squared equals 4p plus q. Sort of minus and sort of write down what you would get, 8p equals, and so on. But if you do that, in the interest of time, your calculator should give you these values. Okay, so what do we need to remember at the end? Well, the key idea is for a complete equation. Okay, for a complete equation, what we need to do is we need to sub them back in, so just the variables are there and all the constants are known about. Find a complete equation. Watch out for this signal here. It's a very common question indeed.